This video is on the objective make a conclusion and interpret the results of a one-mean hypothesis test with the population's standard deviation unknown. And this is using the critical value or rejection region approach. Now this is my second video on this particular objective, so hopefully you've seen the first one. I'm going to do a little less explaining in this one because I did a lot in the first one. Now let's just take a look at the question. So again, if you're unfamiliar with it, please take a look at more instruction. Look at their videos, their notes, their examples, and hopefully those help you. Alright, so Isabella gathered data on the average percentage of tips received by waitstaff. Alright, so this is similar to the first question I did on this objective, another percentage of tips received by waitstaff, but this is in New York City and not Chicago. So Isabella gathered data on the average percentage of tips received by waitstaff in 31 restaurants in New York City. She works through the testing procedure. Now, the null hypothesis, remember, is what's being assumed. So Isabella here is assuming that the average percentage of tips received by waitstaff in all restaurants in New York is 14%. And her alternate hypothesis, what she's testing, is that the average percentage of tips received by waitstaff in all restaurants in New York City is not 14%. Two-tailed test. So you notice the two critical values down here. Her significance level is 10%, and you might notice that the subscript on the t-score is 5%, because remember, when it's a two-tailed test, there are two rejection regions that add up, have an area that add up to alpha. So if alpha is 10%, those two tails have areas of 5% each. So one to the right of 1.697 and one to the left of negative 1.697, those t-scores. Alright, so she took this sample of 31 restaurants, found their sample mean, their sample standard deviation, calculated this t-score, and got 1.489. Now, is 1.489 is the test statistic in the rejection regions that are determined by these critical values? Well, no. 1.489 is between negative 1.697 and positive 1.697. So 1.489, that is not in the right tail or left tail rejection regions determined by these critical values. So since that is not in the rejection region, we are going to not reject or fail to reject the null hypothesis. And again, if you're selecting this one, you're also selecting this one here, that the test statistic is not in the rejection region. Now, if the test statistic was 1.697 or greater, or if it was negative 1.697 or less, then you would reject the null because the test statistic would fall within the rejection region. Now, if we are rejecting, we're not rejecting, we're keeping the null hypothesis then. So this assumption that the mean percentage is 14%, the average percentage of tips received by waitstaff in New York is 14%, we're going to keep that and not support the alternative. So we're going to say that there's not enough evidence to support this statement, that the mean percentage of tips kept is not 14%. We're going to say that there's not enough evidence to support that. All right, and I'm sure that's what they're going to have us do in the second part. So great there. Read your answer explanations, please. And again, using the information above, choose the correct conclusion. All right. Now again, we did not reject the null hypothesis, so it's either one of these. Now the reason we didn't is because our test statistic was between those two critical values, right? Not in the rejection region. So this is it here, not this third reason. See, this is saying the test statistic was greater than the negative one, but it's also got to be less than the positive one, right? If there's two of them, it's got to be between them to be not in the rejection region. So we should not reject the null hypothesis because our test statistic fell between the critical values. So at the 10% significance level, the data do not provide enough evidence to conclude that the average percentage of tips received is not equal to 14%. That was that alternative hypothesis that we're not supporting. Right? We're keeping the null. We're keeping the fact that the mean is 14%. We're going to say that's probably more likely than the alternative. All right. And again, please read your answer explanations. And it looks like if you see the confetti come down. It looks like for that particular objective, if you get 2 questions correct, right, with both parts correct, you'll be done with that objective. So again, take your time, don't rush, don't guess. Right? Make sure you're getting things correct the first time around, so the assignment is shorter for you. The more you guess and the more you get wrong, the longer the assignment becomes because it throws more problems at you to make sure you're mastering the material. So take your time, make sure you're doing things correctly the first time around. Alright, so hopefully watching this video, maybe looking at the more instruction, all help you when you're working on this kind of a problem for this objective on your own. And thank you very much for watching.